This is Mr. Beck Does Your Homework. This is physics homework number 8, question number 9. This is a great problem because it pulls all of your skills together. So let's see what we got. A ball is thrown from the top of a building upward at an angle of 37 degrees to the horizontal and with an initial speed of 17 meters per second. So I've got 17 meters per second at an angle of 37 degrees above the horizontal. So if I were to extend this out straight, then this is my 37 degrees. The ball is thrown at a height of 29 meters above the ground. There's my 29 meters. And it hits the ground 50.1157 meters from the base of the building. What is the speed of the ball just before it strikes the ground? So I'm looking for the speed of the ball. Now, the ball, when it hits the ground, is going to be going in this direction. So how do I figure out that speed? What I need is I'm going to need my x component of the speed, and I'm going to need my y component of the speed. So let's look at this a little bigger. I'm going to have a speed that's coming down at an angle somewhere like this, right? So we'll just say that's what's happening here. That is made up of an x component, and it's made up of a y component. Sorry, that should be a y. So that makes myself a right triangle. I guess you could draw it this way. It won't really matter. So that's my x, that's my y, and this is my total. This is my v total. So what I'm looking for is this v total, and Pythagoras would tell me that a squared plus b squared is c squared. Now this is my y velocity at the end of the flight. This is my final y velocity. So I'm going to need my final y velocity. So that's my v in the y world. And this velocity in the x world, well, it doesn't really matter because the x world, well, it does matter, but the x world, there's no acceleration. So if I know my velocity at the beginning, I know my velocity at the end. So that's fine either way. I get my velocity in the x world beginning or end. So this velocity in the x world should be easy to get to. So let's go back to the beginning. I've got 17 meters per second at 37 degrees. Let me draw that. Here's my 17 meters per second. And my angle is 37 degrees. When I have that angle and this is my monster. The monster doesn't belong in the x world or the y world. But if I drop a vertical down here and make that my y velocity, and this to the right is my x velocity, that's the x component. And I know that my velocity in the x world is going to be my total velocity, which is 17 here, times the cosine of the angle. And my velocity in the y world is going to be my total velocity times the sine of the angle. This is going to always work for me in the initial. This will be my initial y velocity. So let's look at x world first. I know that my velocity in the x world is going to be my total velocity times the cosine of theta. So my velocity in the x world is going to be my 17 meters per second times the cosine of 37 degrees. And that will give me my velocity in the x world, and that is my first velocity and my last velocity and my all-the-time velocity. That is simply my velocity in the x world. So that is going to be this component. Now let's look at the y world. In the y world, I have to find my final velocity. But I know that my initial velocity is going to be this one. It's going to be 17 sine 37. It's the y component of this initial velocity. So my initial velocity is going to be 17 sine 37. I know that my acceleration is going to be negative 9.8 meters per second squared. I'm looking for my final velocity, and I need one more variable, and the variable that I could use here is this height, 29 meters. I know the ball will wind up down 29 meters at the time it hits the ground, so I know that my displacement is going to be negative 29 meters. To figure out something with these four, I know that v squared, my final velocity squared, is my initial velocity squared plus twice my acceleration times my displacement. And I can plug in my initial velocity here. I can plug in my gravity, my acceleration of negative 9.8, and I can plug in my height of negative 29. Now, sometimes you've got negatives and positives, and you've got this is positive and this is negative. Well, in this case, this is going to give you some positive number because it's v squared. This g is negative and my distance is negative, so this is another positive number, so this is going to get even bigger. So whatever this value is, this is going to add to it and get even bigger, and then I'm going to square root. So my velocity is going to be the square root of sum of all of this, right? Well, wait a second, when I square root, it could be positive or negative. I know it should be negative, but in the case of this triangle, so my next step is going to be an a squared plus b squared equals c squared. It won't much matter that it's negative, but whatever it is, that's my y velocity. It's really negative, but when I need to find out my next step, I really don't care that it's negative. Because my last step, which I'll fit in right over here, is that a squared plus b squared equals c squared. If I want my final velocity here, then it's two legs of a right triangle, so a squared plus b squared equals c squared, and this is going to be the speed, so it's not going to be positive or negative, it's just going to be a scalar, so I'm just going to enter it in as a positive number. So my a squared is going to be my velocity in the x direction, squared. My b squared is going to be this velocity in the y, well, you could go back to what you square rooted here, but this value is going to be my final velocity in the y direction, squared, equals c squared. And so c will be the square root of the x squared plus v of y squared, and that will give me my answer for my final total velocity. So c is my total velocity.